Baleen is a filter feeder system inside the mouths of baleen whales. The baleen system works when a whale opens its mouth underwater and the whale takes in water. The whale then pushes the water out, and animals such as krill are filtered by the baleen and remain as food source for the whale. Baleen is similar to bristles and is made of keratin, the same substance found in human fingernails and hair. Some whales, such as the bowhead whale, have longer baleen than others. Other whales, such as the gray whale, only use one side of the baleen. These baleen bristles are arranged in plates across the upper jaw of the whale. Baleen is often called whale bone, but that name also can refer to the normal bones of whales, which have often been used as a material, especially as a cheaper substitute for ivory in carving. Depending on the species, a baleen plate can be 0.5 to 3.5 meters long, and weigh up to 90 kilograms. Its hairy fringes are called baleen hair or whalebone hair. They are also called baleen bristles, which in SEI whales are highly calcified, calcification functioning to increase their stiffness. Baleen plates are broader at the gum line. The plates have been compared to sieves of Venetian blinds. Etymology. The word baleen derives from the Latin balarena, related to the Greek phalina, both of which mean whale. Evolution. The oldest true fossils of baleen are only 15 million years old, but baleen rarely fossilizes, and scientists believe it originated considerably earlier than that. This is indicated by baleen-related skull modifications being found in fossils from considerably earlier, including a buttress of bone in the upper jaw beneath the eyes, and loose lower jaw bones at the chin. Baleen is believed to have evolved around 30 million years ago, possibly from a hard, gummy upper jaw, like the one a Dall's porpoise has. It closely resembles baleen at the microscopic level. The initial evolution and radiation of baleen plates is believed to have occurred during early Oligocene, when Antarctica broke off from Gondwana and the Antarctic Circumpolar Current was formed, increasing productivity of ocean environments. This occurred because the current kept warm ocean waters away from the area that is now Antarctica, producing steep gradients in temperature, salinity, light, and nutrients where the warm water meets the cold. The transition from teeth to baleen is proposed to have occurred stepwise, from teeth to a hybrid to baleen. It is known that modern mysticetes have teeth initially and then develop baleen plate germs in utero, but lose the dentition and have only baleen during juvenile and adulthood. However, developing mysticetes do not produce tooth enamel because at some point this trait evolved to become a pseudogene. This is likely to have occurred about 28 million years ago and proves that dentition is an ancestral state of mysticetes. Using parsimony to study this and other ancestral characters suggests that the common ancestor of Etiocetids and Edentulus mysticetes evolved lateral nutrient foramina, which are believed to have provided blood vessels and nerves a way to reach developing baleen. Further research suggests that the baleen of Etiocetus was arranged in bundles between widely spaced teeth. If true, this combination of baleen and dentition in Etiocetus would act as a transition state between odontocetes and mysticetes. This intermediate step is further supported by evidence of other changes that occurred with the evolution of baleen that make it possible for the organisms to survive using filter feeding, such as a change in skull structure and throat elasticity. It would be highly unlikely for all of these changes to occur at once. Therefore, it is proposed that Oligocene Etiocetids possess both ancestral and descendant character states regarding feeding strategies. This makes them mosaic taxa. showing that either baleen evolved before dentition was lost or that the traits for filter feeding originally evolved for other functions. It also shows that the evolution could have occurred gradually because the ancestral state was originally maintained. Therefore, the mosaic whales could have exploited new resources using filter feeding while not abandoning the previous prey strategies. The result of this stepwise transition is apparent in modern-day baleen whales. Because of their enamel pseudogenes and their in utero development and reabsorbing of teeth. If it is true that many early baleen whales also had teeth, these were probably used only peripherally, or perhaps not at all. Intense research has been carried out to sort out the evolution and phylogenetic history of mysticetes, but there is still much debate surrounding this issue. More work needs to be done to characterize extinct ancestral fossils so that future scientists will be able to piece together a more accurate phylogenetic tree. Filter feeding. A whale's baleen plates play the most important role in its filter feeding process. In order to feed, a baleen whale opens its mouth widely and scoops in dense shoals of prey, together with large volumes of water. It then partly shuts its mouth and presses its tongue against its upper jaw, forcing the water to pass out sideways through the baleen, thus sieving out the prey which it then swallows. Human uses. People formerly used baleen for making numerous items where flexibility and strength were required, including back scratches, collar stiffeners, buggy whips, parasol ribs, crinoline petticoats and corset stays. It was commonly used to crease paper. Its flexibility kept it from damaging the paper. It was also occasionally used in cable-backed bows. Synthetic materials are now usually used for similar purposes, especially plastic and fiberglass. It is not to be confused with whale's bone, meaning the bones of whales, used in carving, for cutlery handles and other uses for the bones of various large species. As a habitat, baleen serves as a habitat for some species from the gastropod families Pyropeltidae, Coculonidae, Osteopeltidae and Neoleptopsidae.